We went up a lot of trees here in the Amazon, and we learned all about the different kinds of creatures that live in the tree tops, particularly the bees, and how much they love or hate you depending on which tree you climb. It was a whole adventure, but crucially, we managed to deploy our first batch of camera traps there to see what wildlife we could find, and I can confidently say that the results are incredible, including some very elusive animals that rarely get spotted, let alone filmed in their natural environment. And we're of course doing all of this in order to start gathering the necessary data to protect, reconnect, and restore the forest canopy of our land, and eventually the wider rainforest beyond. And in this video today, you'll get to see all of those adventures, see all the camera trap footage, and learn about the 2 projects we are setting up to rewild the rainforest canopy. So with all the bits of gear prepared for our first proper climb, it was time to set out and find an emergent tree near the Mandari Lodge, further downstream from our land.
It is doable?
Well, I think so. You might have to join the ropes together. But
It is quite tricky to properly show you the true size of this giant tree, but as a reference, it has to be at least 13 or 14 stories tall. Now, we definitely don't have the skills to figure out how to get up there ourselves, but thankfully, we found the right man for the job. This is OLLIE, Thiago's climbing partner and Mossy Earth member who has spent plenty of time in the Ecuadorian Amazon, and also the rope access pro that has helped us at some of our other vertical rewilding projects with his small company called Ropey Science. Nevertheless, this big tree is still a challenge, even for someone with OLLIE's credentials, but we didn't just pick it to mess with him. We picked it because it is covered in epiphytes, which are these plants that live non-parasitically on the branches of tall trees. And among these, we are particularly interested in the tank bromeliads that can store water up there and will play a role in our project. And this particular tree happened to be covered in them.
so basically the idea is just to shoot it over that massive branch there. And it will come down the other side. And then from that we can tie on the climbing rope and pull it back over.
Do you think it hasn't gone over?
No, we need to try again because it's in the broken branch. Maybe the broken one, it's not. Maybe it's dry. It can be dangerous.
Yeah. I mean, it'll probably come with enough pulling. But the problem with that is it's gonna. If you pull it really hard, it flies towards you. So maybe if everyone goes like over there.
All right, yeah, we'll clear up.
Boom!
So this was not an easy process due to the height of the branch and the sheer amount of epiphytes. However, after quite a few shots and a bit of wrangling, OLLIE managed to hit his target.
I think this is a 60-meter throw line, and as you can see, we've run out of rope.
Huh.
So it's probably 32 meters up to that first branch.
Then it was a matter of pulling the actual climbing rope in place and giving it a final test. And OLLIE was ready to climb.
It's good, but the bees are all like really coming out now.
Now, from this point on, all hell broke loose for OLLIE. The bees coming out of this giant beehive started going crazy, and while they did not sting, they did bite pretty hard.
I think I'm going to come down. The bees are absolutely out of control. Sí. Gracias, muchachos. So this is
There's one in your ear.
I've lost count of where they are actually. It turns out the best view in the jungle is also prime real estate for bees.
So that was our first proper tree. A bit of a rough start, but a start nonetheless. After this, it got dark and we couldn't figure out what to do next, so we decided to head back and give OLLIE a rest.
What just happened to you, OLLIE?
Just bitten in an intimate spot by a bee.
But like 20 minutes after you came down.
Yeah, well, they're all in my socks, and I think they're just making their way up.
For the good one.
Over the next few days, things started going better, and Ollie rigged some more trees without giant beehives, so we could all have a crack at climbing to explore this place a bit more.
As you can see around me, the Canopy is a very diverse place. It's because the Canopy architecture with its different branches and cavities creates a lot of different microhabitats for these different plant species. And actually the plant community that we'll find in the inner canopy will be quite different from what we would find on the branches in the outer canopy.
The crowns of these trees form a complex three-dimensional habitat home to mosses, ferns, bromeliads, and orchids, as well as vines such as ayahuasca and lianas, and even the killer strangler fig. This place is brimming with life, but it is hard to stay up there for long, and we often scared away the wildlife after only a quick glance, so it was time to deploy our cameras.
So the reason we're setting up the camera traps up there is that there are many species that don't even come to the ground of the forest, so they only live in the canopy. So we're setting up the camera traps so that we can capture those species as well.
This was fun and interesting work involving long hours in the jungle with a lot of time spent firing the slingshot and disentangling the line, as well as climbing up and down the rope and often finishing late in the day.
It's such a cool place to be. There's all of this mist in the forest, nice light, and you see all of these lianas, all of these epiphytes. It's really incredible. So I'm gonna meet Ollie up there. He's a fast climber, and we're gonna set up this camera trap up there to see what we can find. So we figured that we would have the camera trap facing this branch behind me. So Ollie is up in a tangle there, trying to get into position so that we can get the camera trap up there facing this branch. It just seems to be connecting nicely to the rest of the canopy and to be a long branch, so hopefully we can capture some wildlife.
Okay, so here we are in the second tree of the day. We just put the camera trap down here. It's facing out on another branch that goes off into another tree. There is an absolute mountain of sweat bees up here. I don't know whether you can see, but they have gone into every single orifice of my body, so we're just going to head down now and get out of this.
And once the first climber went up, the whole crew on the ground would get swarmed by sweat bees, which led to many original attempts at getting rid of them, with mixed results.
This hairstyle is pretty effective.
It's like the spa ceremony. Have you ever done that?
The what ceremony?
The spa ceremony?
Oh.
I think they do something like this.
Together, Tiago, Ollie, and Jaime, our neighbor who took to tree climbing like a duck to water, managed to keep 6 cameras recording up there for about 3 weeks as an initial test run. Now, while we wait for the results to come in, I would like to introduce you to our first canopy project, using a concept which we've named Sentinel trees. And it all begins with the bromeliads.
So I'm up a really tall tree again. This time I'm sitting nicely on the branch. This is a beautiful view, but there's a ton of sweat bees. But the purpose really of being up here is because we spotted some tankier looking bromeliads that essentially means that they hold a bit more water like that. And they're the ones that form these really nice sky wetlands. So just wanted to show you that. And I managed to film one down there that had a bit of water so that you can sort of see how that looks.
And these really hold a lot of water. Just look at how much of it was spilling over during Ollie's ordeal with the bees. It's pretty impressive. That is an abundance of water in a place where it is a scarce resource. So it's no wonder that it is an important habitat for many animals, which for us means it's an interesting place to look to understand what lives here. Take this study here, for example. The authors sampled bromeliads in the Yasuni region looking for amphibians and reptiles, and they found 10 species of frog, 1 gecko, 1 snake, and 2 lizard species inside the bromeliads of the 32 trees they climbed. So this gave us an idea. We are going to pick a certain number of trees where we will monitor what species we find over time using the water in these bromeliads to detect environmental DNA. This will help us detect as near as possible to species level what animals are drinking this water, using the bromeliads as a bit of a bathroom, and of course the ones that use them to hide and to lay their eggs. And since going up a tree is quite a bit of work, we thought we would take the opportunity to also deploy 2 more devices. The first is a camera trap, of course, to allow us to visually identify the species, which, as you will see from our little experiment here, has worked quite well. We'll be using a new rigging system that OLLIE came up with, which allows us to swap the batteries and SD cards without having to climb each tree every time, allowing us to keep the cameras in these trees for longer, with a lot less effort. Then the second device we want to deploy is an audio recorder, and the potential is huge. You see, by monitoring the sound of a rainforest, we can create a soundscape of the biodiversity that lives there, which has been proven to be very effective in detecting the ecological state of that rainforest. We based this on a paper published in Nature, which is super insightful, but more on that one after we launch this, when we get to analyze our first bits of sound. For us, our goal will be to build a soundscape library of how the forest around here sounds like in different stages of recovery. This will essentially give us a clear picture of the species composition in the mature forests and the abandoned cow pastures on our land, and then allow us to compare this with the results we get in the more pristine forests, deeper in the Yasuni National Park, or in the more degraded areas near the oil roads. This will allow us to measure our progress, and we'll be able to provide these datasets to local students to query and publish research from, which has the added benefit of building this biodiversity monitoring capacity in Ecuador. And all of this is part of a broader effort to use our lands to build a hybrid between a research station testing rewilding interventions, a local capacity building hub, and a tourism outpost deep in the Yasuni region of the vast Amazon rainforest to try and create bigger and broader regional impact. And to achieve this, we will be spending around £250,000 here in the next 2 years, covering the 2 projects in this video and quite a few more that we are yet to reveal to you. And all of this work, the buying of the land to protect it, and the development of these projects is only made possible by the support of our Mossy Earth members. People like you, watching this video, that decide to contribute a small amount every month towards our work. We then use this money to build our own rewilding teams on the ground to maximize impact and transparency, and those teams then develop these projects based on good science to ensure they have a solid foundation and ultimately that they are able to restore the wild ecosystems that we all want to see thrive. Right now, we have our own teams in Ecuador, Scotland, Portugal, and Indonesia, helping bring back all sorts of amazing habitats and supporting all kinds of wonderfully diverse wildlife. It's super fun, but above all impactful, and if it sounds like something for you, then please consider becoming a member at mossy.earth. Okay, so that was our first project, and before we talk about the next one, it is finally time to look at the results from our camera trap.
So this here is a canopy highway, and it is essentially a set of branches that connect to another tree and allow the animals to move through the forest without ever having to go down to the forest floor. And as you can see, the branches, they're all a bit more bare because so many animals have been walking back and forth along them. And that is of course why we've been setting our camera traps here. And I can promise you, this place gets a lot of traffic.
It was really cool to get a glimpse of these animals in their natural environment. There were kinkajous everywhere. They are these cute animals in the family of the raccoon, and when they're not busy exploring the canopy, they took an interest in our cameras, and while some were clearly scared, others wanted to get a closer look. And so did this creature. At first, we weren't sure what it was, until it revealed a unique feature. This is of course a 2-toed sloth, and later we managed to see it moving about at its trademark speed. It's an animal we were not lucky enough to spot, despite our best attempts, so it is really cool to have its presence confirmed in our land. And there was of course this charming Saki monkey that was trying to adjust the framing, much like one does when taking a selfie. These Sakis were so nimble. It was beautiful to see just how comfortable they are jumping around like this at 30 meters above the forest floor, even when they are carrying a precious burden on their backs. And we also saw all sorts of other wonderful birds, including some which are very difficult to spot, such as this nocturnal curassow. And then we saw this animal. This is an arboreal porcupine, probably either the Amazonian long-tailed porcupine or the Brazilian porcupine. While this porcupine here, in another tree, might actually be the elusive streaked dwarf porcupine. This would be a very cool record to have on our land, and I think it clearly illustrates why we need to put camera traps up there to understand this place better, and why we need to keep them there not just for a few weeks, but ideally for a few years. The potential is enormous, and it will all be made possible with OLLIE's rigging system. And in case you're curious to see more of this footage, we have cut an extended video of the climbing adventures and the full clips from these camera traps and uploaded it to our Mossy Earth Field Notes channel, where we share regular on-the-ground updates from our projects, ranging from how much the deployed coral has grown to the nitty-gritty of our seagrass and oyster restoration projects, among many others. So I think it's a great way to catch up if you're a member, and if you're not yet a member, but maybe are considering supporting us, it's a really good place to learn about our work. So be sure to head over there and subscribe if it is interesting for you. Now, seeing all of these animals move about the canopy is what inspired our second project. You see, rainforest fragmentation is a big problem because it can lead to alterations to forest dynamics, structure, composition, and microclimate, making the landscape more susceptible to droughts and fires. And the proof is right in front of us, as the only deforested part of our land was so dry that it suffered from a fire that spread through the cow pasture after an electrical pole fell on it.
This happened yesterday, guys. Just yesterday. In about 2 hours, everything was gone. Everything was gone in 2 hours. It's totally burning. Everything is still a fire there. Look at that. So, in this part was amazing. The last time I make a look at this huge tree. Can you see the mark of this tree here? That was a big tree.
None of the forest was burnt, which tells you a lot about why these small pockets of fragmentation are so dangerous, and why a continuous healthy forest is really important. We will be implementing some active measures to recover the forest here, and also to help local people protect and recover their own forests through tourism and other bioeconomies. But for this project, we want to focus on the connectivity of the wildlife populations, and once again, our land is the perfect testing ground. You see, we have this road here that slices the land in two, as well as the open pockets created by the cacao plantations and the cow pasture. This significantly hampers the movement of wildlife, and it is something I noticed myself while filming the wildlife, particularly the various groups of monkeys that tend to stay in the same area. In this corner here, we have a group of red titi monkeys and golden-mantled tamarins. And up here in the more mature rainforest, we have the saki monkeys that you saw on the camera traps. Then on the other side of the cacao plantations, the cow pastures and the road, we have another group of titis and another group of sakis. And further down, near the river, we have another group of golden-mantled tamarins and some night monkeys as well. Now, some of this is due to territory, of course, but what was immediately obvious to me while trying to film the monkeys in this area here was that they always escaped this way whenever we eventually spooked them, regardless of whether we were coming from the road or from the forest. The monkeys here would always retreat along the canopy and deeper into the forest. And that is because their habitat is fragmented. I saw them dozens of times, right here, next to the road, but not a single time on the other side of the road, which was a really clear sign that the lack of a continuous canopy is a significant barrier for arboreal animals like them, who really don't like to come down from the safety of the trees. Now, picture this at scale, with all the fragmentation that exists in these areas that have been logged and have been getting worse over the last 30 years. The problem is quite big. Thankfully though, there is a neat short-term solution we can implement, at least for the animals' sake, which is a canopy bridge. These are simple structures, but they have a proven track record, which we know because our partners at Conservation Evidence collate information on a wide range of practices, and then ask experts to give them a rating based on the papers they gathered. This one has 10 papers backing it up, and it is rated as beneficial because it scores at about 80% in effectiveness, meaning it is effective in achieving its objectives, and 70% in terms of certainty, meaning there is good evidence for it. So we will start by testing the various types of canopy bridges on our land in 2025, and then monitoring the results with camera traps to see which ones work best for most species in our region. One of the challenges we are looking to overcome is how to build a canopy bridge that also works for amphibians, reptiles, and invertebrates that suffer from the same problems as mammals, of course. Because as far as we know, no one has designed a bridge that works for them as well. So if you have any ideas, please leave them in the comments down below and we will try to implement them. Now, all of this testing will allow us to pick the best bridge types to deploy as far and wide as we might be allowed in the region to rebuild wildlife networks and increase the resilience of those populations. And at the end of this whole adventure, it was finally my time to climb one of the giants of the Amazon. One that managed to survive the logging and still stands proudly to this day on our land.
So from up here, I can see most of the canopy of our land, and I must say that it has been an absolutely magical experience to get to know this habitat a bit better and have the chance to explore it here in our land. So I hope you've enjoyed it as well. And just a reminder that this project and all our other projects are only possible because of our Mossy Earth members. So if you'd like to support our work, then please consider heading over to mossy.earth to learn more. And now it's time I figure out how to get down from here and get my feet back on firm, steady ground. Until next time. Cheers!